all of the data that you might collect or that you might be looking at in studies in this course fall within one of 4 different categories. These are called scales of measurement. You've got nominal, ordinal, interval, and ratio. Not ration. Okay, so nominal, ordinal, interval, and ratio. Now, nominal and ordinal, these are what are known as your qualitative measures, whereas interval and ratio, these are quantitative. Quantitative meaning you're dealing with quantities. You're going to have numerical values for interval and ratio that mean something. They're going to be some sort of, the numbers mean something. They are measures, or the numbers count something. Whereas with qualitative data, you're really just looking at categories. So an example where you're looking at categories as opposed to measures or counts could be something like, let's say you have an area code. Maybe your area code is 555. Now, that 555 doesn't measure anything. It doesn't count anything. It's simply just, it's like an address that you've been given by the phone company. The 555 just helps identify you or what area you're in. It doesn't mean that if somebody has a 905 as an area code that they have more of something than you do, or if somebody has a 312 area code, they don't have less of something than you do with 555. So it's just a category that you fit in. So you might see numbers over here with qualitative, but they're not measurements or counts. They're not meaningful numbers that actually keep track of something other than just to fit you into a category. Okay, so nominal and ordinal are both categories. But what distinguishes one from the other? What's the difference between nominal and ordinal? Well, nominal are purely just categories, whereas ordinal data is made up of categories that can be put in order. Now, I stress this word "can" for one simple reason. Let me give you an example where I've got categories that can be put into order. Maybe you're going to go do a coffee run. You're going to buy coffee for everybody in your study group, and so you ask people what size of coffee do they want. Well, coffees at the coffee shop might come in small, medium, large, extra large, and so on. And this is data that is in order, but maybe the data that you collect isn't in order. Perhaps the first 2 people want medium coffees, and then the next 2 people going around the table that you ask want a small and then a large, and then the next person wants an extra large, and then the last person wants a large. Now, my data as I've collected it is not in order, but that doesn't mean that I don't have ordinal data. Ordinal data is data that forms categories that can be put into order. So my data that I've got here, it could be put into order. There's a logical order to it. Whereas with nominal data is purely just categories. Things like on a survey you're asked, are you male or female? Or what's the first pet that you ever owned? Was it a dog, a cat, or a turtle? And so on. So these are categories. There's no particular order to these categories. Even if you had numbers that show up, even if you had numbers in a data set that represent categories, let's say something like males are represented as a 1 in your data set and females are represented as a 0. There's no particular order to these. 1 doesn't come after 0, 0 doesn't come before 1, males don't have more of something. It's just an arbitrary choice that was made to represent the data. Sometimes when you record data, you don't have the ability within the program that you're using to actually put in labels like male and female or dog, cat, and turtle and so on. You have to represent them as numbers. But the numbers are meaningless in the same way that having an area code of 555 doesn't keep track of anything other than the category you fit into. It helps to distinguish you between, or it helps to distinguish between you and somebody who has like a 312 area code. Much like if you're on a, let's say you're on a hockey team, somebody might have on the back of their jersey the number 17, another person has the number 22. There's no order to these. Number 22 didn't score more goals or isn't older or hasn't been on the team longer or anything like that. These numbers just simply help for the viewer, people watching the game, to distinguish between one player and another, or players on the team or the coach or whoever might be watching the game. So numbers are meaningless. They simply just represent categories. You don't even necessarily have to have numbers. You could just be looking directly at the categories, and the categories don't have any particular order. Categories, pure categories, that's nominal data. Categories that can be put into order, that would be ordinal data. Now you might see with ordinal data that you do have numbers. Like a classic example of ordinal data would be placement within a race. First place, second place, and third place, and so on. So you might have numbers. The numbers, again, don't measure or count anything. Instead, they show the relative placement. How did this person perform relative to this person? Well, the first person who came in first place, they ran faster, or they finished in less time. They finished the race in less time than the person in second place. And second place came in before the person in third place, and so on. But notice, we don't have any information given by first, second, and third place as to how close they were to each other. Maybe first place ran the race in 10 minutes. Maybe second place ran the race in 10 minutes and 2 seconds, so very close. Third place, maybe they ran the race in 18 minutes. We have no idea whether or not there was a huge gap between second and third place. That's not in ordinal data. Ordinal data simply tells us how they relate to each other, what positions they take in relation to each other. Small, medium, large, and extra large coffees, I don't know how much coffee is in each one of these. I don't know if the small and medium sizes are almost the same and large and extra large are enormous. None of that is given to me. I only know the order. Now over here on this side, interval and ratio data, these are going to be proper numerical measures or counts. And there's a little bit more of a subtle difference between these two scales of measurement than what we saw over here with nominal and ordinal. Nominal and ordinal are pretty easy to distinguish. Interval and ratio, though, can be a bit tricky. Now, interval, the name itself refers to the fact that there are equal intervals between adjacent categories, between adjacent, yeah, I guess I can say categories. Ratio data is named ratio because there are meaningful ratios of any two values in your data. However, what your textbook might mention that, but what it doesn't mention necessarily is that what's true for interval is also true for ratio. So when it comes to ratio data, we can also say that we have equal intervals between adjacent categories. I'll give an example. or I'll give some examples of interval and some examples of ratio that will hopefully distinguish between the two more easily. With interval data, I have equal intervals between adjacent categories, but that's all that I have. I don't have meaningful ratios between any two values. And actually, another thing about ratio data that can help us to distinguish it is that there is what's called a true 0 point. Okay, so I think the best example that I've ever seen for looking at interval versus ratio would be something like this. Let's say that I'll start off with a ratio. It's going to make a little bit more sense to start off here. Ratio measures are measures where we have meaningful ratios, we have a true 0 point, we have equal intervals between adjacent categories. Let's have a look at two buildings, maybe, that two apartment buildings or two multi-story buildings that are next to each other. The first one has 1, 2, 3, 4 stories. And the second one has 1, 2, 3 stories. So this is building A and this is building B. Now, if I was counting, if I was doing some sort of a study where I'm looking at the number of stories that buildings in the neighborhood have, this would be ratio data. First of all, the number of stories, it's a count. So I know I'm dealing with quantitative data. Do I have equal intervals between adjacent categories? Well, I either have 1 story or 2 stories or 3 stories or 4 stories or 5 stories and so on. Each one tells me, and each increase is an equal increase. If I go from 1 to 2, I've added a story. If I go from 2 to 3, I've added a story, and so on. So we're always adding the same thing. It's not like ordinal data, where going from a small to a medium might mean adding a few extra ounces, whereas going from a medium to a large adds 20 ounces. I really don't have any idea with ordinal. But with ratio, you're always adding the same amount. You're going in equal intervals. The same is true as well for interval data. Equal intervals between adjacent categories. When you go up a unit, you're always going up by the same amount. But what is it about this that makes it ratio? Well, like I said, ratio has meaningful ratios between any two values, and there's a true 0 point. Well, let's start off with the true 0 point. If there was a building that was just being built, maybe next to these two, where they had only started to lay the foundation, this one would be 0 stories. This one would be 3 stories. This one would be 4 stories. A true 0 point means that there are no stories. This building has nothing. It has no height whatsoever. 0 truly means that there's nothing of what's being measured. The number of stories, this one truly has no stories. Meaningful ratio between any two values? Well, how much larger is the 4 than the 3? Let's take a ratio. A ratio is also a fraction. 4 over 3 is equals to 1 1/3. This building that has 4 stories is 1 1/3 times larger than the building with only 3 stories. This is a meaningful ratio. The 1.3333, if I turn this into a decimal, tells me how much larger the taller building is than the shorter building. This is a true or a meaningful ratio. If I had, let me make this a little bit simpler. If I had a building that was 1, 2, 3, 4 stories and a building that was 1, 2 stories, the 4-story building compared to the 2-story building, if I took a ratio 4 over 2, I would get a 2. This 2 tells me that the 4-story building is twice as high as the 2-story building. It's a meaningful ratio telling me that it takes 2 of this smaller building to equal 1 of the larger building. So it's twice as high. So that's ratio data. Data that's acting in a way that you would expect when you're dealing with numbers. This is a little bit different when we're dealing with interval data. Interval data would be something like, let's say I've got, let me redraw my buildings. So I've got my building that is 1, 2, 3, 4 stories, and the building next to it is 1, 2, 3 stories. But let's say that I'm not able to walk right up to these buildings. I'm just looking at them at a distance, and so I'm surveying a faraway neighborhood, something that I just have to look at through binoculars or something like that. And maybe there's something in the way. There's another building, a closer building, that is in the way of these buildings. Let's say that there's a bunch of buildings that are in the way. So I can't see the whole picture. The first story is blocked. And I don't know, because I can't go and walk right up to these buildings. I've got these other buildings that are in the way, obscuring my view of the ground floor. If I'm looking at this building here and this building here, all that I know is that I can see 3 stories that are popping up above or behind this building that's in my way. And this one has 2 stories. So I know that this is true. The number of stories that are visible is what I'm now measuring. And the number of stories that are visible is interval. It's not ratio. Why is it interval? Well, because there truly are equal intervals between adjacent categories. So there is 1 extra story here that is the same as going from 0 to 1, from 1 to 2, from 2 to 3. I'm adding a story each time. That's true here. Each time I go up by 1, I'm adding an equal unit, an equal interval. But I can no longer say that there's meaningful ratios. For example, is this building that has 3 visible stories compared to the building with 2 visible stories, is it 1.5 times taller? So is this 1.5 times taller? Well, I don't know. I can't see where these buildings start off. So I don't know, for example, that the taller building has 4 stories and the shorter building has 3 stories, because I can't see how far down these go because it's being obscured. I only have a bit of the information. I don't know where the 0 point is. If I don't see anything popping up, does that mean that there's no building behind there? I don't know. I can't see behind these buildings. There's no true 0 point. I can't see the ground level where these things start. I can't tell whether or not this building is 1.5 times taller than this building here, or maybe these buildings are both almost the same height. Let me give you another example to maybe help clear this up. When it comes to measuring temperature, there's a few different ways to measure temperature, but let me compare 2 of them. When it comes to measuring temperature, there is the Celsius scale. And 0 degrees Celsius is the sort of the starting point for the Celsius scale. This is where water freezes. And of course, you can increase above 0 degrees Celsius. You could go up to 10 degrees Celsius. You could go up to 20 degrees Celsius and so on. So it can get hotter, hotter, and hotter. You can keep going. But is 20 degrees Celsius twice as hot as 10 degrees Celsius? Not really. 20 degrees Celsius, I know, is 10 degrees warmer than 20 degrees Celsius, but is it double? Is it double the heat? Well, think about what it is that we're measuring. When you're measuring temperature, you're measuring how much heat there is in something. Does 0 mean that there's no heat whatsoever? Not really. Think about it this way. If there was no heat at 0 degrees Celsius, you wouldn't be able to go down to minus 10 degrees Celsius or minus 20 degrees Celsius. And believe me, I live in a place where You certainly can get temperatures of -10, -20, -30 degrees Celsius. So it's possible to go lower. It's possible to have less heat than 0 degrees Celsius. So this is not a true 0 point. It doesn't mean that this is the absolute 0. You can go lower and lower and lower. In fact, there's a point all the way down here. Well, actually, this isn't really to scale, but you can go down to the absolute lowest temperature, theoretically, is 273 degrees Celsius. This is the ground floor. So to go from here up to 10, or to go from here up to 20, is this line here, is this line twice as tall as this line? Certainly not. So you can't take these two values, 20 and 10, and make a meaningful ratio. There's no meaningful ratio when you have something like temperature in Celsius. So temperature in Celsius would be an example of interval data. The same is true for temperature in Fahrenheit. It has its own 0 point that is an arbitrarily chosen point. It's not the lowest you can possibly go. You can have negatives in Fahrenheit as well. Now there is a way to measure temperature called the Kelvin scale. You might have encountered that. If you've taken any science courses, the Kelvin scale starts at 0 degrees K for Kelvin, and that truly is the lowest you can go. 0 degrees K is equals to minus 273 degrees Celsius. The Kelvin scale measures how much heat there is in something, and it does it by using how much movement there is at an atomic scale. If there's no movement in an atomic scale, which is something we don't directly ever witness, but it's the theoretical value you would give if there was absolutely no movement. We can get close to it in a laboratory, but 0 degrees Kelvin is theoretically the lowest possible temperature. You can't have anything less than no movement. So if you get it down to no movement, that's 0 degrees Kelvin. Now to get up to 10 degrees, actually not 10 degrees Celsius, if I had 10 degrees Kelvin, or if I had 20 degrees Kelvin, if I took these two values to get from 0 to 10 or 0 to 20, you can see measuring up from 0, going to 10, or going to 20, this is 2 times as high to get from 0 to go from 0 to 20 as it is to go from 0 to 10. So if you do have an absolute 0 or a true 0 point, what you're going to find is that you can take a ratio and it will be a meaningful ratio. So if temperature in Celsius was interval, temperature in Kelvin is ratio measure.